Okay, so here's where we're going to go through the inorganic stuff. You might remember you got presented with this chart on the data sheet, just a whole bunch of different solutions that you were going to go mix together. So I did this, and actually I did this several times, and with the help of various of my students and my son, we took some pictures of things. So let's quickly go through it and explain what's going on, hopefully in a way that will help you. So we'll start off with just the silver halides. So we're going to take a solution of silver ions, which was silver nitrate, and then we're going to add to one of those some chloride ions in the form of magnesium chloride, and then another one, some bromide ions in the form of calcium bromide, and then some iodide ions in the form, I believe, of potassium iodide. When we do that, we get these three precipitates. Okay, the chloride makes the white precipitate of silver chloride. All of that you should know, of course, from GCSE. The bromide, so silver bromide, is a creamy precipitate. And then the one where we took iodide added to silver ions made the yellow precipitate of silver iodide. So that was a nice GCSE thing, but that still comes up frequently on the A-level, not just in and of itself, but also this is a test for halogenoalkanes. If you take a compound you think is a halogenoalkane, stew it up with sodium hydroxide, you get a substitution reaction in which the hydroxide substitutes for the halide, chloride, bromide, or iodide, which you can then test for by adding silver ions to it. Now, a way that you can tell, if you're not so sure about the difference between white and cream, for example, which particular silver halide precipitate you have, is with the ammonia test. If you add dilute ammonia to these, it has no effect on the yellow precipitate, no effect on the creamy precipitate, but it will help redissolve the silver chloride. So you have, I'm trying to take, when I do these addings, I try to take pictures that are sort of in the process of it. So you can see now that instead of it being precipitate all the way out, most of the precipitate has been dissolved. Now, as I said, dilute ammonia has no effect on the bromide and the iodide, but if you take concentrated ammonia and you add it first of all to bromide, then it starts dissolving that. So again, you can see here's the clear part where I had added in the concentrated ammonia. It's dissolved some of the silver bromide. There's still some silver bromide left in there, but concentrated ammonia had no effect on the yellow silver iodide precipitate. So of course the take-home message here, the GCSE, silver ions plus chloride is white silver chloride, silver ions plus bromide is cream silver bromide, and silver ions plus iodide is yellow silver iodide. With dilute ammonia, the silver chloride will dissolve, but no effect on the silver bromide and iodide. With concentrated ammonia, in other words, much higher concentration of NH3, then the silver bromide will dissolve, but the silver iodide will not. Now, it's worth just a quick extra little bit of physical chemistry here, actually inorganic chemistry. Silver ions love ammonia. Okay, so if you have silver ions, you just add ammonia to it, you will make this nice linear complex that is a silver cation, silver plus cation, coordinated to two ammonia molecules. So this is a coordination compound, okay? And that really, really loves to form, so that the equilibrium constant for this particular reaction, 1.1 times 10 to the 7. So in other words, if you just got silver ions floating around, you add ammonia to it, just about all those silver ions will get complexed by the ammonia. However, we don't really have silver ions when we're dealing with silver chloride, silver bromide, or silver iodide, do we? We have a few silver ions floating around in there, but the bulk of it is the solid precipitate. Now, silver chloride will dissociate to some silver ions and some chloride ions, but look at that equilibrium constant. It's pretty small, isn't it? 1.6 times 10 to the minus 10. So that's why when you add take silver and you add chloride, or take chloride and you add silver, whichever way around you do it, you're going to get that white precipitate. But if we have some silver chloride, like we had here, and we add some ammonia to it, well then some of those few silver ions that are floating around in solution will be snatched up by the ammonia to make this silver ammonia complex. And of course that disturbs the equilibrium, so therefore a little bit more silver chloride, a little bit more of the precipitate will dissolve, making some more silver ions, which will then get snapped up by some more ammonia and making this complex. So therefore you've disturbed the equilibrium again. So more of the silver chloride solid will dissociate to give you silver ions and chloride ions. Some of those silver ions will get snatched up by the ammonia. I could do this all day. Okay, so even though silver chloride has got a really teeny equilibrium constant to turn into silver ions and chloride ions, so silver ions like ammonia so much that some of them will get snagged up into that complex, and you start seeing the silver chloride precipitate dissolving. Now with silver bromide, you can do the same analysis, but look at the difference between the equilibrium constants here. The silver chloride equilibrium complex for splitting up into the ions is 1,000 times bigger than the silver bromide equilibrium constant. So that means if you're going to dissolve silver bromide, you're going to have more ammonia in there to tilt the equilibrium such that you start dissolving it. So dilute ammonia, not enough. Concentrated ammonia, however, is enough to take care of that 1,000-fold difference in the equilibrium constants. Hope you can see where I'm going with the next click, because silver iodide, even teenier equilibrium constant. Okay, it's 10,000 times smaller than the silver bromide. The silver bromide needed so much ammonia to it, you had to use concentrated ammonia. You go down by another 10,000-fold in the equilibrium constants, and even concentrated ammonia can't do anything about the silver iodide. Hopefully that made a little bit of sense to you. Put those observations into context.